Hello everyone, my name is Hazik Kirmani and welcome to the most expected archive series. Today with us is one of the kind of expected problems, PYQs of the work energy power chapter from class 11th physics. It was asked in JEE Advanced in 2019. So it is given that a particle is moved along a path A to B, B to C, basically A to B, B to C, C to D, D, E, E, F and FA. Fine. The initial and the final points are same, isn't that? Initial and final point is same. Okay. As shown the figure in presence of a force. So a force is given and we have to find what is the work done by particle by the force. See, if the force was conservative force, we know the properties of conservative force. It is when the work is done by the conservative force or the work is done against a conservative force in a closed loop, that is always zero. See, it starts from A, it ends at A. It's a closed loop. It will be zero joules if it was a conservative force. But is it a conservative force? I'll say it's not. Usually constant. If a force is constant, it's conservative, or if it is a perfect differential, it is conservative. I'll give you just a trick to find if it is conservative or not. It was used to be taught in classes when we were preparing, but I think now it is like removed from the syllabus. If your force is given as something F1, it's a variable I cap, and F2 J cap, basically like this I cap and J cap. If you want to check if the force is conservative or not, what was the trick? Partial differentiation of F1 with respect to Y, if it is equivalent to the partial differentiation with respect to X of F2. If we check in this case, this side will give us alpha and this side will give us 2 alpha, isn't that? And they are not equal, and thus I say it's not conservative force. So there will be some work that will be done. And now how to calculate that work done? If we see there is only Y component in I cap and there is only X component in J cap, while alpha is already a constant -1. Fine. So it is really an easy equation because forces are constant. See, because in I cap only Y is a variable, and in this figure we can clearly see whenever the work is done across X axis, there is no work that is done in Y axis. Make sense? So can we say, for example, we have to find the work of AB. Can we say it is only due to this thing? Isn't that? Even if we integrate and all, then we'll put limits of X only, isn't that? Because only X has changed, this X axis. No? In Y, what was the displacement? From 0 to 0. Even if you integrate this and put the limit 0 to 0, it won't make sense. It will be 0 anyways. So only this component of force is doing work, isn't that? Displacement ke along ka work. Good. So can we say alpha is -1, and what is Y in this case, A to B? Sir, it's 1. So -1 into 1. This is force. What is the displacement? Isn't that? Work is F dot S when force is constant. And even though the force is not constant here, force is a variable, but if we take these A to B, B to C, if we take these individual parts, we'll get that in the individual parts the force is constant. See, in case of A and B, it is -1 into 1. Alpha is -1, Y is already constant in A to B. What is the displacement, sir? From 0 to 1. So final minus initial in X, obviously. So 1 minus 0, that is 1. So you got that as -1. What is work B to C? You'll say, sir, the work is only done by Y component of force because there is no displacement in X. So we'll take only this thing. How much is this force? So alpha is -1, -2. What is X? What is X from B to C, sir? That is 1. So force is -2. What is the displacement? So displacement is final minus initial. So -0.5. So that gives you, can you tell me? That gives you +1. Good. What is work C to D? Same thing. So only work is done with the I component of the force. So minus Y. What is Y? 0.5. So can we say -0.5 multiplied with displacement? What is displacement? Final minus initial in X. 0.5 minus 1. That is -0.5. that will give you 0.25. Good. This is 1 here, this is -1. What is work D to E? So work is only done by J component of force, isn't that? Because in I displacement is not there. So minus 2I, what is X? 0.5. So can we say this is minus 1, isn't that? What is the displacement? So again, final displacement minus initial displacement. In Y final it is 0, initially it was 0.5, so minus 0.5, so that gives us plus 0.5. What is work from E to F? So from E to F only, this is doing work. I component, isn't that? The displacement is only in X axis. But what is the value of Y? So value of Y is also 0. So the force is 0 basically. No matter what is the displacement, it is already 0. What is the work from F to A? Again, so the displacement is only done by I component of the force. I component, yes, I component. Sorry, only the J component. Why? Because the displacement is only happening in Y axis. And what is the X to calculate this force? Sir, I is 0, X is 0, isn't that? See, X is 0. Because it is just the Y axis on which the work is done. Fine. So basically force is again 0 multiplied with any displacement, that is 0. So -1, just add these things. Work net is the summation of all these works. -1 plus 1 is gone. This is plus and this is plus. So your answer is going to be 0.75 joules. That is the answer for this question. It was really easy to solve such a question, and this can be probably repeated anytime because it is a kind of trick question. It looks variable force, but you don't need to integrate, because on these, if you take these parts from A to B, B to C, the forces are always constant, and you can easily use the formula force dot displacement is work. So I hope you enjoyed this video. See you with one more beautiful question. Till then, bye bye.